hour, 59 minutes, and 26 seconds. So 12:15.
Oh, well then y'all can log in with me. Here we go. 5 minutes. Watch me go through
Nah.
She's only doing one problem.
Watch me whip. Nope.
We're not doing anything around here.
Let's see. We did that one.
Miss Holcombe, did you ever dab back in the day?
Huh?
Nice.
Yeah.
Didn't ask you to do it for me.
You didn't ask. Okay. Go to this one.
I did.
All right.
I was asking for it.
Extra example, solve, finding all solutions, express the solutions in radians and degrees. Okay, so let's take a few notes here because this is different than the last one, where it says all solutions. This means, when they say all solutions, it means because there's no restrictions. If there's no restrictions at all, your answer will have that whole plus 2 pi k, or like Brody realized yesterday, plus pi k works. So it means that your answer is going to be of the form, hey, here's where it works on the unit circle, but then if we add a coterminal angle, then you can hit every time. So that's how you know when your answer needs to be in that form if it says find all solutions. Okay, so we've not worked a tangent one, so here we are. Recall, before I even get into this, tangent, if you remember, is what over what? That's when it's y over x, or sine over cosine, right? Remember that tangent equal to 1 means it's a 45 mark, because that's where x and y match. Tangent equal to root 3 or root 3 over 3 is either a 30 or 60 mark. If you look at this one, if you want, we can go ahead and just move the negative over. But here's the trig function by itself. The negative would need to move to the other side. So tan of x would equal negative root 3. Recall that we said tan of 30 is the one with more 3's. Right? Yeah, that memorized makes life easier. And then, so if tan of 30 is the one with more 3's, and that is not what we're facing here, then we want the one that's tan of what? I'm just going to draw a line. 60. Tan of 60, which is where it's just root 3. Remember that?
Yep.
So now we know we're dealing with 60. Reference angle. It does say negative root 3, so now we have to look at our unit circle. I'm going to pull mine up. Okay, got my unit circle up, coming back over here. Let's ask ourselves, so here's what we have. So right here is where you would ask yourself, what angle has a tan, which means y divided x, value of negative root 3? This is me taking notes to let you know how you would proceed. You would ask yourself, what angle has a tan value of negative root 3? Well, the fact that tan is negative tells me which quadrants am I in. Tan is where you divide x and y. In your 4 quadrants, where would you divide x and y and get a negative number? Quadrant 2 or 4, because that's where 1 would be positive, 1 would be negative. So we're in quadrant 2 and 4. We We've already said that we're looking for the 60-degree reference angle. So now go to your unit circle and find the 60-degree reference angle in quadrants 2 and 4. By the way, they should be directly opposite of each other. Red means wrong. Like if you did this one correctly, but then you went here incorrectly, something should be off. They should be opposite of each other because it's the same reference angle. And now you pull the radians and the degrees from that. So I'm going to go in order. First angle is 120. Second angle is what? 300. So separate, got degrees, radians, so x is, we said 120 and 300, and what were the radians? You have to flip back over. Okay. Now it said find all solutions, which means we need to account for
negatives.
Coterminals.
No.
Right? So this is where you say plus, this is degrees. So 360K plus 360K. What would this one be plus? 2 pi k, 2 pi k. Now, you do need to be able to say where k, just say it one time, is an integer. Is there a more succinct way to write this?
Mm-hmm.
Yes. And that would be because the 120 and the 300 were directly opposite of each other. They're separated by what rotation measurement? They're separated by 180 degrees. Now, this, I would take this. This is fine. I'm just trying to help you level up. But if you notice that they are directly opposite of each other, you could say, I'm going to hit this one, and then I'm going to write plus pi k, or plus 180k, because then it would hit that one without me having to say it. So if you can see that, that's great. If you don't see that, you'll get there one day. So let's put it on your paper though. I'm going to put dot, 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 or I could just do 120 plus 180k. Or I could do 2 pi over 3 plus pi k. So either one works. That's when you're asked to find all solutions. What if you're told, hey, just tell me the solutions between 0 to 360 or 0 to 2 pi? Then that means you don't have to write the whole plus 360k plus 2 pi k. So it's still the same question. It's just when they say right here, find all solutions, and then they give you parameters. These are your parameters right here. When they give you parameters, they're saying that they only want you to look at the unit circle and account for that. It means there is no plus 2 pi k or plus pi k. Nonsense. Also, the fact that it listed it in radians and degrees, that means they want you to list it in radians and degrees. If they had listed just radians, that means they want yours in radians. If they listed just degrees, they would want yours in just degrees. So let's solve the first one. The trig function is sine x. We've got two things to do. First, you need to add or subtract anything to the other side. So we got 2 sine x equals a negative root 3. Then we've got to divide by what? 2. Okay, once again, I'm writing what you would ask yourself to try to train you to know what exactly does this mean. It means what angle has a sine, which means y, value of negative root 3 over 2. Well, think, where is y negative? Where all is y negative? Quadrant 3 and 4. So that is telling you where to look for your answer. We have 2 answers to pull, and I'm going to label them right here. I'm going to label RAD for radians and DEG for degrees. So you'd go to your unit circle, and you would find where y is negative root 3 over 2. And you can just list it as a list. Now, if you accidentally got caught up in this and you wrote plus 2 pi k, I'm not going to mark it wrong. I would just put a slash through it and circle the directions, but I wouldn't take points off for that. All right, let's do the next one. We've got 2 cosine squared of x equals 1. If this is bothering you, then I'm going to change colors. Consider rewriting it with x for cosine and y for sine. So this is just 2x squared equals 1. And then maybe now you can see, okay, I'm just dividing by 2 and then I'm square rooting. Maybe you don't see that as easily right here. So rewrite it as a regular equation with x or y, and then you may see how to solve it. So I'm going to divide by 2. And then cosine squared needs to be just cosine, and I undo that by square rooting. So cosine x equals, but you've got to remember, if you square root, the next line better have positive, negative. Because now what's happened is we don't know where that 1/2 came from. If it came from a positive times a positive or a negative times a negative. And then to take the square root of that, that is the same thing as the square root of 1 over the square root of 2. Which means you can square root the 1. So that's a 1 over square root 2. Now, is there a 1 over square root 2 anywhere on your unit circle? No, because that's not rationalized. So you would need to rationalize it. So we're not looking for 1 over root 2. We're actually looking for root root 2 over 2. Because it's positive negative, this means, we've already said this once before, let's refresh you. This means any quadrant. You're looking at all four. Any quadrant. Now let's make our list. Now I'm running out of room, so I'm going to arrange mine like this. Now you should know kind of in the top of your head, like, because root 2 over 2 is the, what in quadrant 1? What angle? Root 2 over 2?
The 45.
45, right? So we're hitting all the 45-degree reference angles.
So technically, for doing that, you could just do 45 plus.
You don't want to because the directions only want us to stay in the 1 unit circle, so it's just better to say here are the 4 answers.
Okay.
Yeah. You only want to do the whole plus intervals if they're telling me.
Can you do like plus
It
90
would be 90,
pi though? Okay.
I think. Because 180 minus 45 is the 135. So the difference between all the 45s is 90.
Okay.
So what'd you get? Let's see. Did you get 45, 225, and 315? 135, 225, 315? Okay, so those are all regular trig equations that are just a matter of adding and subtracting something over, and then square rooting, right? Now let's practice when the trig equation is in quadratic form. And it sounds really complicated. When you look at it, you're probably like, oh Lord, here we go. Let's just stop here. It's actually not that bad, okay? This is where we basically take the trig equation and we say, you know what? That is really just a quadratic. You solve the quadratic and then you come right back to that trig function that you took out, okay? All right. So this is showing you, hey, now we're in quadratic trig equations. How do I know it's a quadratic trig equation? Because I have a sine squared and a sine. Look at all of the last practice problems. There was just a regular old single trig function. Now there's more than one. And one's squared and one's not. Okay? First of all, notice the directions right here. They say solve sine squared beta minus sine beta equals 0 in, and then it gives you this fancy notation. This means they want the answer in radian form. They want your answer in radians. And they want you to only stay on the unit circle. They don't want you to worry about plus or minus k and all that. When you first look at this, you probably think this is really complicated. So why don't we just let sine of beta be the letter y. Let's rewrite it as in terms of just y. We'll draw an arrow. So this is sine squared beta. That would be what instead? Y squared. minus sine beta, so that would say minus y, and then equals 0. Look at that. Way better, right? Now, don't forget from Algebra 2 and from college algebra,
It'd be difference of squares, wouldn't it? Or
you're close. No, not yet. This is actually easier than difference of squares. This has a
GCF.
Yeah, there it is. So let's do this. Let's label your paper right here as, you can either write solve by GCF or you can just write in big letters GCF to show that here's an example where we're practicing solving by GCF. So what's the GCF? They both have a y. I'm going to pull it to the front, and that would leave me with y minus 1 in parentheses. And you might be thinking, no, wait a minute, that doesn't help anything. It actually does. And that's because now we can use something that we've used before. You may not remember the name of it. The zero product property. So basically it's saying this crap times this crap is going to give me 0. Anytime two pieces of crap get multiplied together to give you 0, what do you know about one of those pieces of crap?
Negative.
Sorry. Did I lose you by calling it all crap?
Mm-mm.
Anytime you multiply two things together and you get 0, then you know what about the two things? If I multiply and I get 0, one of them's got to be 0. That's the only way to multiply two things and get 0. So the fact that we see this times this is 0 tells me, hey, zero product property, which means we don't know which one's 0. We just force them both to 0 and solve that. So right here, this would be y equals 0, y minus 1 equals 0. That's the zero product property. You're saying, okay, well either y is 0 or the y minus 1 crap is 0. Now here you solve, add the 1. So you come to 0 and 1. Now, in the original problem though, I didn't have the letter y, I had what? Sine of theta. So I'm going to draw a line to say I'm coming back in here and I'm replacing y with sine of beta. And now you're right where you were in all the other problems. This is saying what angle, if beta throws you off, change it to an x, by the way. You can make that an x, like sine of x. But this is saying what angle has a sine value, or the letter y, of 0. What angle has a sine value of 1? So go to your unit circle. You need to, right here say what angle has a sine, which is y, value of 0 and 1. So where is y 0? On your unit circle, where is the y value 0? Y value 0 here and here. Where's the y value 1? Right here and here. So those are our answers. So now it wanted it in radians, so we only enter the radian values. So I'm going to come back over here, and I'm going to say, and you can write it as one list, or you can write it up underneath. It's up to you. But basically for 0, it was 0 pi, or you can say 0 degrees, because that's the same thing, or 0 pi, or you can write just 0. And then it was 180, which is pi. This one was, where is it? I just realized this is positive one. I highlighted that one. Don't let me go too long. I think I just saw the one. Is that what you were about to tell me? Yeah, sorry. I'm glad you caught it. That means that you're actually doing really good with it then. This is definitely positive or negative one, and the goal was where is sign positive one, so it would be just the pi over 2. I didn't mean to confuse you there. And then you could circle those two. I like to say, like, here's my answer here, here's my answer here, and then I like to be like, okay, so my final answer is, and then I shove them all together. You don't have to do this. That's just me. You could circle the two separate answers and say, here you go. We have 2, 4, 5. No, give me.
You said one problem.
Oh, I know, but then y'all said it had 2 hours till brackets had to be
An
locked
hour
in.
and 20 minutes.
Yes. That's fine, but y'all better lock in with me tomorrow.
Oh, you don't have to waste my gas? Yeah.
Did you do the algebra one screen or the growth screen? Mine's on your screen. You just got what?
I
If I could drive all the way
did
to Greenman, I think I'm chill driving all the way to.
algebra 1.
53 minutes?
It's 53 minutes
Screen.
away.
It's
moving
moving
by
by
itself.
Yes.
It's only 19
Off the back
questions.
one.
I know, I was just asking. No,
Will you hit stop on that?
I'll come.
it's moving by itself.
I know.
add it.
Well, I don't add it to the list.
It's good now. It just seems to turn off, turn back on. Turn off, turn back on.
Yeah, I mean, that's honest. Like, I was